This screencast goes over how to add and subtract rational expressions. Remember, when you have fractions from back in middle school, you have to be able to have common denominators in order to add or subtract fractions. Same idea holds for rational expressions. For example, if I have n squared over n minus 3 minus 9 over n minus 3, I have common denominators. They both have n minus 3. Since it says to subtract, we take that negative to the 9, and we have n squared minus 9 over n minus 3, keeping my common denominator. Now, unlike with fractions, you can't just cross out the n's and reduce that way. You have an expression. So we have to simplify this rational expression like we did earlier. Factor my numerator, which is n plus 3 times n minus 3. Denominator's already factored. Cross out any common factors of numerator and denominator, which in this case is n minus 3. And that gives me an answer of n plus 3. Now, usually we don't have common denominators. For example, I might have 15 minus 8x over x squared minus 5x plus x over x minus 5. Now, when I don't have common denominators, I have to start by factoring that denominator that I have. So I've got 15 minus 8x over that denominator factors. I can factor out an x, and we have x times quantity x minus 5. My second denominator doesn't factor. It's already factored. So we write down our x times x plus 5, x minus 5. When we're finding that common denominator, we are looking first to see what do the two denominators share in common as a factor, and that would be the x minus 5. We also have to include any factor of either denominator, and in my first denominator, I have x. So my common denominator is x times x minus 5. My first denominator has both of those parts. My second denominator is missing the x. But I can't just multiply the denominator by x. We have to multiply numerator by x also, because really that x divided by x is a fancy form of 1. And we multiply by 1, we get the same thing that we multiplied by. However, it's going to look in a little bit different format. So here's what I've got. I still have 15 minus 8x over x times x minus 5 plus x times x is x squared. So I have x squared over x times x minus 5. Now I have my common denominators and I can add. So we are going to write my answer in standard form when I add them. X squared minus 8x plus 15 over x times the quantity x minus 5. And like in our earlier example, we have to check, can we factor that numerator, which we can in this case. It factors into x minus 3 times x minus 5. And that's important because it allows us again to simplify. I have a common factor of x minus 5 in numerator and denominator, so I can reduce that, and that leaves me with my final answer of x minus 3 divided by x. Let's show you another example. This one has 4d over d squared plus 10d plus 21 plus d over d plus 7. Again, don't have common denominators, need to factor just like I did before. So we have 4d over d plus 3 times d plus 7 plus d over d plus 7, because d plus 7 is already factored. My common denominator I'm looking for this time, both denominators have d plus 7, and my first denominator also has d plus 3, so I need d plus 7 times d plus 3. All right, so we're going to multiply our second fraction by d plus 3 over d plus 3, since that's what's missing from my denominator. So I have 4d over d plus 3 times d plus 7, because it already had the common denominator, plus d squared plus 3d over d plus 3 times d plus 7. And now that I have common denominators, I can add. Again, our denominator stays the same. When we add numerators, we get d squared plus 7d. Can we factor that numerator? Yes, we can. We can factor a d out. So I have d times quantity d plus 7. And again, that's helpful because I can reduce, since both numerator and denominator has a factor of d plus 7. So my final answer in this problem is d over d plus 3. Let's give you one with 3. We have 2 over a minus 3 plus 7 over a squared plus a minus 12 plus 1 over a plus 4. Again, need to factor. Well, my first denominator is already factored. My second denominator is not. That factors into a plus 4 times a minus 3. And my third denominator also is already factored. So again, I'm looking for a common denominator. 2 of my denominators have a plus 4, and 2 of my denominators have a minus 3, so a plus 4 times a minus 3 is that common denominator. First denominator is missing a plus 4, so we are going to multiply by a plus 4 over a plus 4. Second denominator is good. Third denominator is missing a minus 3, so we are going to multiply by a minus 3 over a minus 3. So that gives me 2a plus 8 plus 7 plus a minus 3. And notice I just added all of my numerators over a minus 3 times a plus 4. Now I actually kind of did 2 steps at once here. Part of that is I'm running out of space. Combine my like terms. I've got 2a and an a, which is 3a. 8 plus 7 is 15, minus 3 is plus 12. So I have 3a plus 12 over a plus 4, a minus 3. I can factor out of 3 in my numerator, so I'm going to do that. That is helpful because, again, it will allow me to reduce, because numerator and denominator have a factor of a plus 4. And that gives me a final answer of 3 divided by a minus 3. Now, you don't always have common denominators that are very obvious. Sometimes you have 2 denominators that are factored, but don't have anything in common. For example, I have here 3 over a plus 2. Whoops. Give me 1 second here. I have 3 over a plus 2 plus 8 over a minus 5. Denominators are factored. They don't seem to have anything in common. But remember, a common denominator has any factor of any denominator. So we're going to have a minus 2 times a plus 2 times a minus 5. First denominator has the a plus 2, but is missing the a minus 5. So we are going to multiply by a minus 5 over a minus 5. Second denominator has a minus 5, but is missing a plus 2. So again, we're going to factor numerator and multiply by a minus 2 over a minus 2. Multiplying out, I got 3a minus 15 over a plus 2 times a minus 5 plus 8a plus 16 over a minus 5 times a plus 2. And combining what I got, we have 11a plus 1 over a plus 2 times a minus 5. Numerator doesn't factor. That's my answer. And that concludes this screencast on adding and subtracting rational expressions.